We finish until this part. We want to check the distance measure with the DTW. So the DTW means the dynamic time warping. So this is the algorithm. Let me explain with the example. So we have two series. Series means we have a data with a time sequence. So this is the data in the time 1, this is the data in the time 2, this is the data in the time 3, and so on. So we have 1, and then 4, and then 5, and then 10, and then 9, 3, 2, 6, 8, and 4. We have another series Q. We have 1, 7, 3, 4, 1, 10, 5, 4, 7, 4. Okay. So if we plot the data, it will be something like this one. So I would like to know what is the distance between P and Q. You know the distance measure when we learn from the similarity. We have the Euclidean distance, we have the Manhattan distance, but now we have another distance measure, we call it dynamic time warping. So we are making empty cost matrix. So the cost matrix, this is initially empty. So we have P and we have Q, and we put the data like 1, 4, 5, 10, 9, 3, 2, 6, 8, 4. And then this is the data for Q. It's 1, 7, 3, 4, 1, 10, 5, 4, 7, and 4. Fill the cost matrix using the formula starting from the left and bottom corner. So we need to fill in from this low left bottom corner. And then we will use this formula. So what is this formula? Let's see one by one. The first, we have M1, 1. 1, means it is the P position 1 and then Q position 1. The P1, the value is 1, and the Q1, the value is also 1. Then we do this formula, absolute value of 1 minus 1 plus the minimum of M I minus 1. I it is 1, so then I have the 0, 0, Mi, j minus 1. So it means I is 1 and j minus 1 is 0. And then I have I minus 1, which is 0, j, which is 1. Okay. Then we will check what is M00. Nothing. Because it is nothing, we can assume this is 0. What is M1, 0? Nothing. Then we can also say this is 0. What is M0, 1? Nothing. So we can also say this is 0. So the minimum of 0, 0, and 0 is 0. Then 0 plus 0, it is 0. What about the next? 1, 2. 1, 2 means I need to check the P1, Q2. So it means 1 minus 7. Okay, I put 7 minus 1. Actually, it is the same because we have the absolute. 1 minus 7, it is minus 6. When we do with the absolute, then it will be positive 6. And we will check the minimum of m, the minimum of 1, 2. So we will check based on this formula. What is it? We will check m, I minus 1, which is 0, j minus 1, which is 1. And then we have another, which is I, this is 1, j minus 1. And then we have m, I minus 1, which is 0, comma j, comma 2. Then it is nothing, so we can say it is 0. We have m 1, 1. This is 0, 2. This is nothing. Nothing. Then we will check only based on this one. M 1, 1. What is 1, 1 here? It is 0. Then we have 6 minus 0. X 6 plus 0. Then the result is 6. Next, 2, 1. Here is the position 2, 1. So we will check the m position 2, which is 4, and then position 1, which is 1. So we have 4 minus 1, which is 3. And then we will check the minimum of the surrounding. So it means we have m 1, 0, m 2, 0, and then m 1, 1. So this is nothing, and we have 1, 1, which is 0. Then 3 plus 0, it is 3. What about next? 1, 3. 1, 3, we have the value is 1, the value is 3, so 3 minus 1. And then we will check the minimum of the surrounding. Okay. This is, we have m 0, 2. This is nothing. And then m 1, 2. And then we have m 0, 2. Sorry, 0, 3. Okay, 0, 3 is nothing. So we have the m 1, 2. What is 1, 2? 1, 2 is 6. Because we have nothing here, so this is the remaining. Then we have the value is 6. Then 2 plus 6, it is 8. So we put the value 8 in this cell. And so on. Okay. So let's see, we have m 2, 2. What is m 2, 2? We want to check the value, which is 7 minus 4, plus the minimum of m11, m21, m12, m11, m12, and m21. So among those three values, what is the minimum? The minimum is 0. And we have 3 plus 0. The result will be 3. So we put this value into this cell. And so on. So we can put all the cell with the respective number. So we will just do the subtraction and then find the minimum. Subtraction, find the minimum. Subtraction, find the minimum. Let's say 3, 3. What is 3, 3? Here we have 5 minus 3. We have 5 minus 3. And then plus the minimum of this one, and this one. Then we have the option whether it is 5 or 3 or 4. So the minimum is 3. We have the new value 2 plus 3, which is 5. and we put this part into the cell. Okay. So we need to calculate for all the cells until it is completed. And we call it the complete cost matrix. So this is the complete cost matrix. After we have this cost matrix, so we need to identify the warping path. What is warping path? We want to find what is the minimum value from the top right onto the left bottom. So, for example, from the top right, the value is 15. Then I need to check which value is the minimum in the surrounding. The surrounding means this portion, this, and this. We have 18, 15, and 18. The minimum value is 15. So we select 15 and we go to the next value is 15. And again, we will check where is the minimum. The minimum of the surrounding of this 15. We have 19, 15, and 14. So the minimum is 14. Then we select 14 for next. After we select 14, again we need to select the minimum in the surrounding of 14. 15, 13, 17. The minimum is 13. Then we go to the 13. And so on until we finish it to the bottom left. After we have this one, we need to check what is the minimum of between 3, 0, and 6. So the minimum is 0. And we can have something like this. This is the warping path. This is the warping path. Let this warping path series be called as T. Let T is the value for this warping path. So 15, 15, 14, 13, 11, 9, 8, 8, 4, 4, 3, and 0. In order to get the distance, we need to calculate the final distance. So this is the final distance calculation. The big D equals to the sigma di. This is the d, small d, for all values, and then we divide with the k. What is k? K means the number of the data that we have in this warping path. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 data. So in this case, we have k equals to 12. Then we will do the summation for all the data and then divide it by 12. So we have the value 8.62. Because this is the distance between P and Q using the dynamic time warping. Now let's suppose we have another example. This is another series. This is the series 1 and this is the series 2. The series 1, we have 1, 1, 4, 10, 9, 3, 2, 6, 8, 4. And then the series 2, we have 1, 4, 10, 9, 3, 2, 6, 8, 4, and 4. Now we can plot it. So the series 1 is the blue, and series 2 is the orange. If you look at the graph, it shows that those two series are similar. But we need to measure the distance. If you look at this value, it seems that the value has a delay with 1 period. Then we can apply again the dynamic time warping. So you can generate the cost matrix. Okay. After you generate the cost matrix, you can identify the warping path. The warping path means from the top right onto the bottom left. So you will see like this one. In this case, we can calculate the distance. Okay, how many of them? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then we will add all the values because all values are 0 divided by 11. Any number, any 0 divided by any number, it will be 0. So the distance between the series 1 and series 2 is 0. So that's one example that we can do with the time series. So now I'm going to explain about the text data. So actually there are still many more about the time series, but I didn't want to explain everything. So just have the very brief explanation about the time series and the singularity measures. So now I will continue to the next chapter, which is about text data. In the industrial engineering, it is also important to understand the text data. We can categorize the text data into several kind of structured data. The first is the structured data. The structured data means like in the table. So you have like this one, example, home loan, loaning. So it means the person who loans his house, a lender who is the owner, and agency. So there's an agency office, and what is the amount of the loan, and then what is the term. So you can represent this into a table. But this kind of data, we put it into one kind of format. Usually we call it as JSON, JavaScript Object Notation. Here another data, multimedia. So for example, nowadays it is common to see the advertising in the website, in the mobile phone. Let's say you want to find a house, you want to rent a house. So the house picture will appear, and then there will be information whether it is already sold, or it is already rent, or it is still available, and etc. So we have the text inside the figures, or you have like free text. Free text means just a text like news. Or we have another kind of text which is hypertext. If you learn the web, we have the hypertext, or we call it the HTML. This is hypertext markup language. So we can make website. The website is based on the hypertext, and for every of the text, it will be in the kind of tag like this. So the text data, we will store it into a text database. or sometimes people call as the document database. Text database is usually related with the IR. Okay, what is IR? In this case, IR is the information retrieval. Large collection of documents from various sources. We can have like news articles. We can have the database about news. We can have database about the research paper. We can have database about books. So what kind of books that you already have and what kind of books that you want to save into your repository. Digital libraries, email, web pages, library database. So yeah, those kind of things we can say it as the text database. Usually the data is thought as a semi-structure. Semi-structure means you can have the table like this one, but some of the columns may not be in the good structure. Maybe you can see this one is, for example, shop ID. And then this is the shop name. And this is the review. So customers can do review. And in the review, they can have anything. They can type anything. So this is the semi-structure. In one table or in one column, it is structured. You can see the shop ID, you can see the shop name, but in the review, it is totally unstructured. I can say that the shop is good. They help me to select a good product. So if you put like this review into your database, this kind of data is unstructured. Then we can have the semi-structure. Traditional information retrieval techniques become inadequate for the increasingly vast amounts of text data. Nowadays, people tend to have another text database, not using this kind of table, but they have their own ways to save the text database. So in the data mining for text, they have a particular domain. They call it information retrieval. So it is a field developed in parallel with the database system. And the information is organized into a large number of documents. And the information retrieval problem, for example, we want to locate the relevant document based on the user input. So for example, I have the keywords or the example document. So this information retrieval is a typical IR system, like the online library catalogs or the online document management system. What is it? For example, I have, so I can check any paper or any research paper. This is a text database or this is a collection of papers. And let's say I want to find keywords data mining. So when you type data mining, so those are the documents. We have the documents, we have the documents, we have the document, and so on. So we call this is the information retrieval. the typical IR system, we have the online library catalogs. So we call this is kind of catalog. And then this is also a kind of online document management systems. So there are some differences between the information retrieval and database system. DB or database, we have some problems that are not present in IR. For example, in the IR, you cannot update. So like this one, you already have this document management system. You cannot do any update because you are not the administrator. So if you are the user, then of course you cannot do anything. You just have this kind of system. And then there is no transaction management. There is no such as like buy or sell. And complex objects. So in complex object, it is only text. Usually it is only document. But in the DB problem, in the database, you may have something like, for example, you have your student ID. And then you have your name, student name. And then you have photo or picture. So if you put picture in the database, so this data is image. SID is number, you have student ID number, you have student name, this is text, but the picture is image. So it is complex. And in the information retrieval, usually we will not consider any image. In IR, we have some problems which are not addressed well in the DBMS. For example, the unstructured documents. So if you have news, so these days we have the World Cup. So if you put news about soccer, where do you want to put the category? Whether it is in the sport or maybe we have a new category, World Cup. So yeah, any news now they are focusing on the soccer, so they put a new section, World Cup section. In the database, yeah, we cannot do that one. The unstructured documents cannot be classified directly. Approximate using keywords. Approximate search using keywords. So yeah, we need to find the good keywords to find some documents and also the relevance. So we have basic measures for the text retrieval. We have two measures, precision and recall. Precision means the percentage of retrieved documents that are in fact relevant to the query. Retrieve, relevant. We call this is the correct response. So for example, I have this precision formula. It is the relevant intersection with the retrieve. We want to get the number of them divided by the number that the document has been retrieved. So we have all documents, this one. In the precision, we want to find the relevant and the retrieve divided by the retrieved document or the documents that you already got after your searching. Recall means the percentage of documents that are relevant to the query and were in fact retrieve. So the recall means I want to know how many of the relevant and retrieve documents divided by the number of relevant. So I can say the number of relevant and retrieve divided by the relevant. Okay. So you need to see this one in different way. We call this is recall. If we want to check the relevant and retrieve based on the relevant document, and we call this is with precision. We call this is precision if we want to check the relevant and retrieve divided by the retrieve documents. For example, we have a system or an IR system, and it returns 8 relevant documents, and there are 10 irrelevant documents. So the keyword is returns. This returns means I got the documents. So I have 18 documents, and 8 of them are relevant, 10 of them are irrelevant. Okay. There are a total of 20 relevant documents in the collection. So in total, the overall documents I have 20. But after I search the documents, I got only 18. So there are 2 remaining documents that are not retrieved. So what is the precision of the system on this search? And what is its recall? So the precision means the number of retrieved and relevant documents. The number of retrieved and relevant documents. So we have 8. Among the 8, what is the formula here? I want to divide with the number of retrieved documents. So how many documents that I can get when I search it? So we have 8 plus 10. Then the precision will be 8 divided by 18. What is the recall? Recall is the relevant and retrieve, which is 8. And we need to divide with the total relevant documents. The total relevant documents we have 20. Then we have 8 divided by 20. Okay. Now we have another example, question 2. For a given query, there are 16 relevant documents. The precision for the query is 0.4. And the recall for the query is 0.25. How many documents are in the result set? We know the precision is the relevant plus retrieve divided by the retrieve or the document that you can obtain. So I can say that is the result set. So I do not know how many of this and how many of this. What I know is only the number of relevant documents. What is recall? Recall means we want to get the retrieve and the relevant divided by the number of relevant documents. The number of relevant documents, we have 16. So we can get the retrieve and relevant document, because we can see the value of the recall is 0.25, and then we have the number of relevant document, which is 16. So we can know that the relevant and the retrieve document is 4. 0.25 multiplied by 16 from this recall formula. So what is the result set? We know that the relevant and the retrieve document is 4, then we have 0.4 is equal to the 4 divided by the result set. Then the result set is 4 divided by 0.4. Then we have 10 documents in the result set. Okay. So keyword-based retrieval. A document is represented by a string which can be identified by a set of keywords. So what I mentioned to you before, when I do this one, it is searching based on the keyword. I want to search based on the keyword data mining. So if I look at this paper, if you open it, so you can see that the keyword is data mining. Okay. The keyword is data mining. That's why we can extract when we type data mining. We have queries. Query is a kind of expression. So when you try to find something from the web, you can do with this expression, whether, let's say, you want to find car and repair shop. So you need to combine with some keywords. Or you want to find tea or coffee. Or, for example, you want to find DBMS, but not Oracle. So this kind of keyword is available. For example, in YouTube, in Google, YouTube, you can also search with some keywords like this one. So the queries and retrieval should consider synonyms. So for example, I know repair. Repair has a synonym with maintenance. So if I use the word repair, then the query or the system should also give the result with the word maintenance, because they are synonyms. There are major difficulties. So, for example, if the word is synonym, the keyword T does not appear anywhere in the document, even though the document is closely related to the T. For example, the word data mining. You know, in the data mining, we have many fields. Let's say, I do not want to use the data mining keyword here, but I want to know if there are some papers related to machine learning. Okay. So nowadays, the word machine learning is similar with the data mining. Okay. And then if you look at this one, for example, they have the word machine learning. The contents are representing the data mining, even though there is no keyword data mining. So this kind of thing, we have the synonymity, and sometimes we need to deal with the polysemy. The polysemy means the same keyword may mean different things in different contexts. For example, mining. The word mining, it is, maybe you can see the mining. If you learn data mining, of course, it is about the data. But the mining itself, let's say it is coal mining. The original mining is for this one. This is the mining. But data mining has different meaning with this kind of mining. So we call this is the polysemy. One word mining can have different meaning. So in the text database, usually we have some ways to measure the similarity. So in the time series, we learn about the similarity. In the text database, we can also deal with the similarity. We can find the similar document based on the set of common keywords. Answer should be based on the degree of relevance, based on the nearness of the keywords, or relative frequency of the keywords, and etc. So the basic technique is we need to check the stop list. I'm not sure in Korea what is the meaning by the stop list, but in English, we have some words that are deemed irrelevant, even though they may appear frequently. For example, the, of, for, with. So it is sometimes not necessary for counting the frequency. And if you look at an article, there might be a lot of and the in English. And it does not represent anything. Stop list may vary when document set varies. So if it is in English, then this is the stop list. But in Korea, maybe you have the stop list like none or un. It is not necessary or it is not meaningful. So this is example for stop list that we can exclude. So we need to check the stop list and then we can remove it before we do the similarity. In English, we can also do with the stemming. Word stem. Several words are small syntactic variants of each other since they share a common word. For example, we have drop. Drop in a singular noun, just single. Or we have drugs in the plural noun. It means there are many drugs. Or we can have drug as a verb. So one word can be represented in different forms. So when we are trying to calculate the text, so we will do the word stem or stemming, and all of them will have the same original word. We call it the stem. So we just retrieve the original word, which is drop. Even though they have different meaning, maybe one is the singular noun, the other is plural noun, the other is verb, but we can just have only one word, which is job. There's another way for the stem. For example, this one, motivational. motivational, we can stamp or we can cut into the original word. Let's say this is becoming motivate. Emotional, we can also stamp into emotion. Emotionally, for example, we can stamp into emotion. So every words that have like explanation, emotionally, or something that you want to expand the words in English, you need to find the original word. The original word is emotion. And after you do this stemming, you can calculate the frequency. So I want to know how many word emotion in your text. And the frequency is the number of occurrence of the word in a document. Usually we have it as the ratio. Maybe in one document is 3. Maybe the word truck we have 3. The word store we have 5. Maybe the word car we have 2, for example. So we will convert it into ratio. So maybe this is 10. Then this is 0.3. This is 0.5. This is 0.2. Okay, so we will it as a ratio. And we can do the similarity matrix, which is the closeness of the document to a query. We can use the cosine distance. When you learn the similarity in the first part in our lecture, the lecture. So when we deal with the first part, the distance, we have the cosine distance. So you can check later what the cosine distance example. So that's why when we do the final exam, there might be some contents from the materials before the mid exam. Some of the similarity or distance measures will be from the materials before the mid exam. So when you do the final exam, please make sure that you know about this one. That's why last time I told you, if you have the cheat sheet paper, you can have the page number 1 as the material for the mid exam, and then the other page can be the material for the final exam. So you still have the contents. Anyway, for the final exam, please also prepare the cheat sheet paper, and you can write anything. And of course, the contents from the mid exam until the one until before the final exam will be the scope for the final exam. Okay, let's have a break. Okay, I will continue after the break.